For this problem, we were given four values, two vectors and two arguments of said vectors. So for the first vector, it was 12. And I found the components of the vectors by knowing that 30 degrees, its argument, that the 30, 60, 90 degree triangle had ratios of m, 2m, and m root 3. So by doing this, I found that the components of this 12 vector is 4 root 3 and 6. For the second vector, I did the same thing because it has a same special right triangle, just a different reference angle of 60. And I found that this, for 18, it had components of -9 and 6 root 3. This is negative because it lies in the second quadrant, because this angle is really 120. It just makes a reference angle of 60. For the first part of the real problem, I had to add the vectors together, giving me a resultant vector of 4 root 3 minus 9 and 6 plus 6 root 3, which comes to be about -2.07 and 16.39. By doing Pythagorean theorem to solve for the magnitude, because it does make a triangle, a right triangle, I found it to be root 273, and that equals about 16.5. Now to find the direction of that new resultant vector right here, I'd set up a triangle to give me a visual of what I was looking for, and then set up a law of sines ratio because I had all the information. It was a side-side-side triangle, and I could just easily do that to find the angle. And so the resultant angle is technically 84 degrees. That's a reference angle it makes, but the real angle is 96 degrees because it lies in the second quadrant. So it has to be more than 90 degrees. Now I had to subtract the vectors, giving me a resultant vector of 4 root 3 plus 9 and 6 minus 6 root 3, which comes out to be 15.9 and -4.4, meaning that this vector will lie in the fourth quadrant, which we'll get to later. So using Pythag again, I actually found that this magnitude of this vector is the same as the other vector, which is root 273 and about 16.5. That was a complete accident. The math is right. I think it's just fun. Doing the same thing as I did last time, I set up a triangle to give myself a visual, and seeing that it's a side-side-side with a right angle, I know that I can set up a law of sines ratio and solve for this new reference angle, which came out to be 15.5 degrees, but because it's in the fourth quadrant, it has to be greater than 270 degrees and less than 360, so the reference angle is made by the angle 344.5 degrees. For the last part of the problem, I had to do a dot product, which is just multiplication of the vectors. So that resulted in 6 times 6 root 3 plus -9 times 4 root 3, which actually came out to be 36 root 3 minus 36 root 3, which gives me 0, meaning that the vectors are perpendicular to each other, and that the distance between them, like right here, this angle is 90 degrees, which is really fun.